everyone. Today my butter will teach all of us calculus lesson today. Right? Is that right, butter? I'm going to teach all of us the calculus lesson today. Right? Thank you, butter. Thank you. Say hi to everyone and we will learn calculus together. Okay? Thank you, my boy. So, that is my day today. Talking to my cat. So, that is like fun. So, let's start with the calculus lesson. My butter had posted the question on the board. So, let's read together. A driver rides a car at a speed of 48 meters per second and see a stop sign 130 meters away. She presses the brake and her position function is as t, respect to t, as is position function, equal 48t minus t to power 3. The question asks, will she go beyond the stop sign? So imagine you ride a car on the road and then you saw the stop sign far away from you, the distance of 130 meters. So the distance is 130 meters. Now, when you see the stop sign, your reaction is press on the brake to stop your car. Usually when I stop the car, my car still go beyond that a little bit, right? Depend on how we brake the car. Do we brake abruptly or do we brake very hard or we slightly press on the stop sign? I remember one time I was caught by police saying that I didn't stop my car, but actually I did press my car. I did stop because that's the natural when we learn the rules, but actually maybe I stopped quickly and I rolled it away. So here you go. If you learn calculus, you can argue with the police. I'm just joking, right? Yeah, but anyway, the scenario is very similar. So now think about this, like the police stop her and say, no, you didn't stop. But actually, based on calculus, we can calculate our time and prove that whether our car go beyond the stop sign or before the stop sign, right? So let's see how we solve this problem. So hopefully my butter cat had helped me to do this better today for my teaching. So let's see how it's going. So a driver rides a car, and this is the position function. So in this problem, we don't have to develop our own formula because the question already gave us a formula. So it helps us reduce our task a little bit. The other problem I posted before, we have to base on the word problem scenario to establish our own equation. But this one already gave us the equation. So let's see what equation is that. So this is position equation as respect to time equal 48t minus t to power 3. Now, we're going to take derivative of this. And why do we take derivative? Remember, the position function show your car driving on the curb like that, right? Let's say your car driving. So sometime you might go up, you might go down, and the stop sign right here, right? So from here to here, it's 130 meters. Now, this is the stop sign, tell you to stop. So it depends on, usually after we brake, the car still go a further distance. So our position function is the curve. And to find the derivative, to find the instantaneous velocity at that point of the curve, we find the tangent to the curve, right? And that is the instantaneous velocity, which is vt, on the curve. We want to find the slope, the rate of change, right, at that moment. And Vt is the derivative of S phi of t. So basically, if we take derivative of position function, it means we find the slope of the function at a certain point, at a certain time. And S phi of t equivalent to Vt, instantaneous velocity. This is we learned already in the other question, right? So now I'm going to show you how we derivative this question. So remember S phi of t equal Vt, right? And we just take derivative. Instead of using the limit and long rules, now we learn the short rules already. We just take derivative of it very easily, which is equal 48 minus, bring the 3 down, t squared. Reduce this to 1 power. So now we have the velocity. The matter is, at the time when you break the sign, you cause a force to stop your car, right? And when your car stops, your velocity is 0, right? So now we set up as equal 0. So now we solve for, after we set this equation equal 0, we solve for the time. So this will show us that how long does it take you to stop the car when we solve for t, right? So let's solve that. So I'm going to move the 48 over. So I have minus 3t squared equal minus 48. When I separate number on one side, variable on the other side, so we can solve it, right? So now we have 2 negative. We can multiply both sides by negative because that's the rule. We still keep the balance side of the equation when we do that, right? So we're allowed to do that. Multiply both sides by negative. So this become positive, this become positive. So now we solve for t squared by divided by 3 both sides. So we have t squared equal 16. So to solve for t, you have to take square root of it, right? So square root of 16, and let's see how much it is. So square root of 16 and equal 4 seconds. So she stopped. The time taken for her car to stop when the velocity equals 0 is 4 seconds. So now, because we know the time, we can substitute the time back to position function. Because remember, this is position function. So when we substitute the time in this position function, we realize how much her position at that time, how far her car go. So S of 4, right? We substitute the t here by 4 seconds will be equal 48 times with 4, right? Because that's the t, substitute by 4, minus 4 to the power 3. So let's see how much we got. So 48 times 4 equal 192 minus 4 to power 3 equals 64. So 192 minus 64, we got 128 meters. So her position function for the time taken her to stop her car is 128 meters. Now, if her car is from here, and the stop sign from here to here is 130 meters, then her car go beyond up to here. Let's say up to here, 128 meters. So you can answer now, she stopped the car before the stop sign. So the answer will be, she will not pass the stop sign. So that's how you answer this question. And you see the purpose, I put this easy question on the board so that to show you, to prove to you that yes, calculus help us to solve the problem in our reality. And set the problem like this is real application to our life, right? So that's why I'm putting this question on for you to see. So I'm end the video now, and thank you for watching, and sorry about my cat. I would like to, it's just for fun to introduce to you my friend, my best friend, my birdie. And so maybe he want to say goodbye to you as well, because he teaching me this lesson. Now I show you. So let's see. Okay. Hi, Bera. Thank you for teaching me. Okay, so thank you and say bye to everyone for today lesson. And thank you for giving me such a blessed day. Okay, my boy. Bye, everyone. This is my precious boy. I love him so much. Okay, bye for now.